Hello. Hopefully everybody got the memo to start at 2:30 today. Let me just check my Gmail to make sure everybody got that memo. Okay. All right, is anybody in here taking the test yet, by the way? Okay, so Nicole, since you've taken it, you're not allowed to talk to anybody about it. Again, you have until Tuesday night to take that test. And as I said in the announcement, I'm taking into consideration the fact that we did not have a Zoom meeting, and I did not record a meeting for the physical layer. Thank you, Nicole. And also, we didn't speak that much about the data link layer. So I want you guys to take the test anyway, as is. And I will look at statistically the answers. I can look statistically at the questions that were answered regarding physical layer and see if there was a significant amount missed. And I'll make decisions based on that. I'll probably end up making a curve because of that. Having said that, I hope that, and when I put that announcement out about studying the physical layer, no, the test is over chapters 1 through 5, not just physical layer. I was just pointing out that it would be good to go watch that video on the transatlantic cable. About a 40-minute long video. I know it's kind of long, and it's history, but it's interesting, and it also brings up some other elements and some other points regarding physical layer. Also, Googling for and looking up Sputnik and understanding how Sputnik, which was the Russian satellite, the original satellite that anybody launched, not just Russia, but anybody in the world, successfully launched a satellite, why that actually started the internet. And I think that's important to understand why. And I don't think I spoke about that in class, but Sputnik is why we have the internet today as we have it. Okay, so I had just started talking about IP version 4 in the previous class, and we were just about at the end of that chapter 5. There was just a couple more slides, so I wasn't going to, excuse me, worry about going back through the last part of the chapter 5 PowerPoint presentation. I want to introduce you guys to subnetting. And there is a pretty significant assignment for subnetting on Blackboard. I don't know if I find my mouse here. One sec, I can't move my mouse off the screen. You guys see my second screen there? I can't move my mouse over to it though. Hang on one sec for me. Frickin' Zoom. Oh, I see why. Let's adjust that a little bit. There we go. You guys see my mouse now, right? Yeah, okay. Hopefully. So which screen are you guys seeing, by the way? Are you seeing the screen with the announcements for the other class, or are you seeing my display stuff? What are you guys seeing? You should be seeing screen 2. Give me one sec here. Okay, good. I just want to make sure I'm on the right screen because things are displaying a little bit differently today. Maybe Zoom pushed out an update over the weekend. I had a fun weekend because a company called Grandstream, by the way, let me just mention this because this is significant for this class later on in this semester. Grandstream. First of all, has anybody ever heard of that company called Grandstream? Has anybody ever heard of Polycom? Has anybody ever heard of Yealink? Or I'm sure a lot of you have heard of Cisco. Grandstream is a major manufacturer of and a major supplier of voice over IP telephones and telephone equipment. They pushed out an update over the weekend, like Friday at midnight, and it broke many phones and voice over IP devices in the world. And so I was on the phone today with Grandstream, as were probably 1,000 other technicians from all over the place saying, well, you know, we broke it. But it brings up a good management point. And I kind of shot myself in the foot here because I've always been of the, I've always said, do not turn auto updates on. And this also has to do with your desktops as well, and certainly your servers. Microsoft is a strong believer in turning on and enabling automatic updates. Has anybody ever had a situation where your computer auto updated in the middle of the night because you left it on and it closed a file that you were working on, or something didn't work right after the auto update, or the update failed? Well, that's kind of like what happened with Grandstream. And so as a rule of thumb and as a good practice, a good management, MIS management practice, is to not allow automatic updates to be pushed to anything. Workstations, telephones, cameras, certainly not servers, and certainly not devices that are mission critical to your employees. Employees can't use their telephones, you know, salespeople or whatever, or whatever they're doing. They're kind of dead in the water. They're almost dead in the water because although a lot of people use email, a lot of people use the internet, business is still conducted on telephones. So I had been turning on auto update on the telephones because I thought, well, what possibly would they update that could screw stuff up? Well, they screwed a lot of stuff up. So I learned my lesson. What I had to do, and I've been spending most of the weekend doing, is logging into the customer's devices that I was able to get access to and downgrade. In case you guys didn't know what that term was, it's the opposite of upgrade or update, downdate. Downgrade back to the previous firmware. First of all, does everybody know what firmware is? Unlike software, it is software, but firmware is basically software that resides in computer chips. And sometimes we call it embedded software. Okay, firmware is embedded software. Unlike an operating system, which gets automatically loaded, it usually gets saved into the chips of your computer or the device that you're using. And so when you turn that device on, that's the first code that it reads. That's called firmware. So firmware upgrades, if a firmware upgrade fails, usually that can, not usually, but a lot of times that can render the device unbootable. Has anybody ever had that issue before where you did try to do, and this is more of a tech thing. Most end users do not do firmware upgrades, but occasionally you're asked to, like if you have a Dell laptop or a Dell server and there are certain things that you have to do on that server, read larger hard drives, for example, they ask you to boot off of a special CD and do what's called a firmware or an OS upgrade. Well, a lot of times if that firmware fails, that upgrade fails, you end up doing what's called bricking. What does that sound like that is? And I'll get to the subnetting in just a minute, but this is, since I've been dealing with this, I thought it was important to talk about this. What is bricking? What does it sound like bricking is? Anybody? Anybody have any idea? Take a guess. Turn on your mic or type. Exactly, when you turn it into a brick. So has this ever happened to you, Hans, or do you just know what that term means? It happened to a friend. So what were they updating? Were they updating a modem maybe? It happens a lot when people are trying to update their gateway devices, their modems, their Netgears or their ASUS modems. If something happens during the firmware upgrade, you could potentially brick the unit, which means it's basically no better than a brick. You might as well just throw it through the window or throw it away. I have a few bricked items. Or I've bricked a few items in the day, but yeah, it's not a good thing. So we want to try to avoid bricking. So the first way to avoid bricking is don't allow automatic firmware updates, and do updates only when you know you have a long period of time, just in case you've allocated some time in case of updates that you add, or the firmware that you upgrade is bad, is wrong. We can't just assume. And Microsoft and Apple have both been guilty of this. They've both pushed out automatic updates overnight or over a weekend that they then had to quickly downgrade or send out announcements and say, well, that update that we pushed out, it's got a problem. Please downgrade or update this update. They'll put in another update. Swapping parts for his new computer and started up and a storm surge happened. Yeah, so stuff like that, unfortunately. A storm surge, so he was updating firmware during a storm. That's pretty dumb, by the way. Or are you just talking about an electrical surge? Oh, it was pretty dumb. Okay, so yeah, don't do mission critical stuff during a storm outside, if a hurricane's coming, stuff like that. Anyway, that's the kind of stuff I was dealing with this weekend. So again, fun real world examples, and you guys will probably encounter situations where you want to go against the manufacturer's recommendations and not enable automatic updates. Now, having said that, you've got to be very diligent and make sure that you periodically do check for updates, that you have a maintenance schedule, and that all of your assets, and we talk about this again in chapters 10, 11, 12, all of your assets, your network assets, need to be put in a spreadsheet or a database, and a maintenance date or maintenance dates applied to them. So periodically a flag pops up which tells you or a technician or somebody to go check this unit out, or these units, or this could be software even. Check this asset out and see, does it need to be updated? Are there updates? And then an appropriate methodology should be put in place to doing an update. You need to make sure you've got plenty of time. You need to do an update on one. If you've got 100 devices, for example, do it on one not very important device, or not very well-used device. Test it, make sure that the device hasn't been bricked or that it's operating properly. Then you can go back and update all of the others, either maybe temporarily put them on automatic update and then turn that back off. But it's one of those things that this kind of stuff causes network managers hours and hours and hours of lost time. Many updates, by the way, many updates are very, very minor. They're bug fixes, or they might be fixing security holes, which may be significant. But the thing about a security hole or a security vulnerability is it's not going to affect, it's the likelihood of a security vulnerability affecting you, especially if you're a small entity, is very low. It's kind of like, has anybody accidentally left their car unlocked, or the door to their house or their apartment unlocked? Yes, that's a security vulnerability if you accidentally left it unlocked. Or has anybody ever done this? I have been dumb enough to leave the back door of my house open. Left it cracked open and came home and realized it was still open. But because I'm at the end of a cul-de-sac, it's a quiet neighborhood. It's not it's not in a bad neighborhood. I'm not a big security target. That vulnerability did not affect me, except I got a high electric bill. Yeah, so again, left the key in the front door. You might want to consider another boyfriend. No, I'm kidding. Totally kidding. That happens to the best of us, Nicole. So that's my point, is that a lot of these vulnerabilities that are pushed out and they sound really serious. Oh my God, you got to fix this immediately. Yeah, it could be an issue. Could be an issue, but the likelihood of that issue happening varies. If you're not a very big target, if your assets are already fairly well protected behind firewalls, or you're obscure, you have a little time. We have a little saying in the networking world that obscurity is a delay for security. Obscurity is no replacement for security, but it is a delay. In other words, obscure something, so maybe it's not secure, it's not locked behind a door, but you put a blanket over it, so somebody doesn't see that major asset in the corner. Anyway, so subnetting. I want to talk about subnetting today. So let me get back to where I need to get to. Hang on one sec. So I can't answer any questions about the exam until tomorrow evening, unless anybody's having any tech issues taking the exam. But content-wise, I can't talk about it yet. We'll talk plenty about the exam on Wednesday. Okay, so we're going to go to we're not going to go into chapter 6 yet. We'll do that tomorrow. I want you guys to look at the subnetting first. So we go to course content here. I think it's in order, but if not, I'll point it out here. Okay, I put it in order. So we used to just jump right into chapter 6, 7, and 8, and 9, and then we went back to subnetting. But I thought, since chapter 5 is talking about the transport and network layers, aka layer 3 network layer, that's where subnetting comes into play. So under subnetting here, I have got a little calculation tutorial, which I want everybody to go through this tutorial, and I'll start it with you today, and I'm going to introduce you to subnetting for those of you that don't know what it is. And this is pretty complex, and this is a totally foreign concept to a lot of you. You guys might know what an IP address is, or some of you might not know at all what an IP address is. I've mentioned it a few times. You guys have gone to ipchicken.com to look up an IP address, but do you really know how they're derived, what their structure is, why they're important, those kinds of things? So there's a subnetting assignment. There's actually 2 versions of a subnetting assignment that you can do. I recommend that you do the paper PDF version first. If you go look underneath the assignment section, you'll see a subnetting tutorial version 1, and then a subnetting tutorial, the online version. Excuse me, not tutorial, assignment. And let's go through this tutorial first. Okay. First of all, a couple of good tools to use. What does it do? That's a good question. I will probably make it do so that you guys have a little bit of a weekend. How about if I make it do Saturday night? Is that good enough? Or tomorrow night? What you prefer? How about Saturday night? You definitely need to get it done in the next couple of days, because you might have some issues with it. But I'm kind of leaning towards making it Saturday night. But we don't have a whole lot more time, so exam 2 is going to come real quick here, and then exam 3. We might have to make exam 2 due like Monday or Tuesday. We'll see how far we get this week. So I need to blow that up a bit. I can't read it well myself. Okay, let's see if these links are still valid at all. Let me take a look at them here. These are just some links on subnetting from other people that might explain it a little bit differently if you want to go through those. There's an easier way to calculate a Class C, but let's just talk first of all with respect to my notes. Let's talk about what a Class A, a Class B, and a Class C subnet are first, because that answers a lot of questions that you might have already, like what is a subnet and what is this 192.168. So if we simply search for Class A, B, C subnetting, we can see the Wikipedia here. I'm not sure if the wiki on Class A, B, and C is the best, but let's take a look at it. It's been changed a bit recently, and you'll notice it's called classful networking as opposed to classless networking. CIDR, that's the slash notation. So we're not talking about slash notation yet. Okay, we're talking about using a subnet mask, which looks like an IP address. It's the same number of digits. If you remember, we're talking about IP version 4, 32 bits, 32-bit address space. That's 2 to the 32nd power. Okay, well, bits are either ones and zeros. Let's see. Let me see if I can find the one. I know it's in my notes too, but let's see if I can just quickly find it here. Okay, this is a fairly good link. This is a regurgitation of stuff you can find all over the internet about different class sizes. Okay, so a Class A address. If I were to say, I've got a Class A IP version 4 address, that's where only the first octet, we call each of those 4 pieces, you see in this Class A example here, see a 1.0.0.0. Each one of those digits in that case is called an octet. And the reason we call it an octet is because it's made up of 8 bits. 1, 1, 1, 1, 1, 1, 1, 1. And then another 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. We put the periods in for us as humans so that we can read them. So a Class A is any address in which the first octet stays the same and the remaining 3 octets vary. Entities like a country or a large company would be allocated an entire Class A. Also, as you see here, there are reserved Class A ranges. In other words, you will never see any public address on the internet that starts with a 10. It's a reserved range. So 10 dot, basically, I'm gonna put an asterisk here because a lot of people already know what an asterisk is. Usually in the Windows world, in the Mac world, if you type in an asterisk, that means wild card. In the networking world, we don't really use asterisks, we use zeros to mean everything. So Class A, a reserved address, 10 dot anything dot anything dot anything. That's a Class A address. How many Class A subnets can there be in the world? 256 Class A's. Why can there be 256 Class A networks in the world? Because it's 0 to 255, except we can't use 10 because it's reserved, so there's really 255 Class A's in the world, which can be allocated to different entities. And again, this is large. These are large. 256 Class A's, that equals, by the way, 2 to the 8th power. And you probably should memorize, if you have not already, at least up to 2 to the 8th power. Can you guys do that in your head, by the way? The powers of 2 up to 8? It's pretty easy. You just double 2 every time. So first of all, what's 2 to the 0? This is a trick question. 2 to the 0th power. Hopefully you remember back to algebra and your business calculus. And you're correct. A lot of people think it's 0. But yeah, 2 to the 0th power is 1. 2 to the first power, which is the first significant power that we care about, is 2. So 2 to the first power is 2. 2 to the second is 4, and then 8, and then 16, and 32. I've got 5 fingers up, so 32, that's 2 to the fifth power. And then 32 doubled is 64, and then that doubles 128, and then 256. So I've got 8 fingers up here. So 2 to the 8th power equals 256. Okay, keep that in mind. Also, as I've mentioned before, we start counting at 0. So each one of those octets, if I was to rewrite them again, is anything from 0 to 255, because we start at 0, just like the Mayans did. Here's another way to write that. So this, all I'm writing down is just various ways to express an IP version 4 address. It's any number from 0 to 255 dot, any number from 0 to 255 dot, any number from 0 to 255 dot, another number from 0 to 255. So in the case of U of H, for example, most of the addresses at U of H are 129.7 dot something dot something. So I'm just going to write dot wildcard dot wildcard. That means, and that's because we have been assigned, U of H has been assigned this entire net block. It belongs to us. 129.7, nobody else. It is an autonomous net block. It's called an autonomous system number. For short, we call that an ASN. And that's where, and I showed you this before, you could go to aaron.net and you can look up net blocks. Hopefully you've experimented or done this already, where you've gone to aaron.net and you typed in your IP address, or the IP address, not the internal. You could type in the internal address, like if on your computer you were getting 192.168.0.53, for example. Type that in and see what it tells you. It will tell you that that is an internal net block. Okay, but if you were to type in, let's ignore that for a minute. If I typed in 129.7.anything.anything, it'll say that that's University of Houston's net block. That happens to be, that size is called a class B. A class B is 2 to the 16th power. What's 2 to the 16th power, by the way? Anybody know off the top of their head? You could Google it if you want. I know it off the top of my head because I'm an old school programmer. It's 65536. So that means that potentially University of Houston could have 65,536 unique addresses, unique assignments here at U of H. Now you lose some addresses because of the way we split things up. It's kind of like, think of a subnet, and I'm getting a little bit ahead, but think of a subnet as a large length of wood, like a long 2x4. The longer the 2x4, the larger the subnet range is. Every time you chop that 2x4 in half, and you might ask, well, why do you chop 2x4s in half? Because you want to share it. You want, let's say you've got 2 schools here at University of Houston, and you need to give half the addresses to one college and half the addresses to another college. When you chop a 2x4 by, let's say it's 20 feet long or 12 feet long, do you end up with 2 6-foot pieces? No, you don't, because when you saw a piece of wood in half, you end up with a little sawdust on the floor. In other words, there is some waste involved when you chop things up. Kind of the same concept with networking. When you chop networks up into smaller pieces so that you can allocate, and this is why we chop them up, so that we can give one piece to College of Business, one piece to the MIS department, one piece to College of Education, one piece to the police department. We have to chop all these little pieces up into different subnets for different lands for management purposes and for controlling the network. So you end up with some loss. So think of the analogy of sawdust. When you chop something in half, you end up with a little bit of loss. So going back to a Class A, first of all, there's 256 Class A's in the world. If we can vary, if you had a Class A, like let's say you were the United States, and you have the entire Class A of 128. I don't know if USA does or not, but let's say it does. How many bits are left over here? If this stays the same, there's 8 bits there. How many bits are right there? Remember, there I've got a total of 32 bits, so it's 32 minus 8. So, yeah, thank you, 24. So 32 minus 8 is 24. That means in a Class A, that's 2 to the 24th power number of hosts. What's 2 to the 24th power? Again, you could Google for that. It's about 16.7 million. That's a huge network chunk. So that on your home networks, for example, if you give a 10.0 something address, you can have a home network with 16.7 million nodes in it if you wanted to, but nobody's going to have 16.7 million nodes of anything at their home. Otherwise, they are a country. So Class B, just keep in mind, a Class A, there can be 256 Class A networks of size 16.7 million. In a Class B, that's where we vary just the last 8. So the first 8, the last 16. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Those don't change, as in the case of U of H 129.7, but then we can vary 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. I'm just going to write all zeros there. We can vary any of that part of the address. So we can have 129.7 dot anything and allocate however we want. This is actually a binary net mask, defining what the range is, basically. That's all that a net mask is it defines how big your network is. It's actually easier to conceptually learn this in binary because it's kind of easy to see. Okay, anything that's a 0, you can see through that. Oh, I can see, and I can change that. Anything that's a 1, I can't see through that. It's whatever my internet provider gave me. They said, here, your block is 129.7, you can't change that. Or your block is 132.6, you can't change that. Everything else you can change, okay? We don't ever write it down that way when we put it into computer networking. We convert all of those 1s and 0s into decimal. That's where the 255.255, in this case, .0.0 comes in, okay? All 1s in binary translates into 255. Excuse me. So there's the first set of 1s, there's the first set of 255s, and if it's helpful, I'll space it out a little bit.
I have a question.
Yeah, go ahead.
So is this similar to the phone number as well? Like UVH, the phone number starts 713 and then 743. Is that like a specific identification?
Kind of, except in terms of telephone numbers, we don't really use the concept of a subnet mask. We just associate telephone numbers based on an area code, based on a prefix. It used to be. It's not really the case anymore, but it used to be that a particular prefix, and that's the first 3 digits after your area code. So if your number is 713-825, for example, that 825 is your prefix. That's supposed to relate to a specific neighborhood or a specific part of town. That used to be how it worked. For networking, not really the case anymore because all telephone numbers are just digital pointers anymore anyway. So the concept is a little bit different. This is a decimal net mask. This is what you actually type in, or this is what DHCP learns. And you see that in IP version 4. If I was to go look up my net, if I click on the networking button and go check, or if you open, actually easier, even easier, just open a command window here. CMD or IP config. I'm sorry, IP config. Scroll up past that jump there. There's my IP version 4 address 10.0.0.6. But because of this subnet mask 255.255.255.0, this is telling my computer that the first 3 octets here don't vary on my network. Only that 4th one varies. So everything on my local network is .6, .7, .8, .9, all the way up to .255. Okay? So you guys understand that concept so far? A class C subnet is where the first 3 octets stay the same. 1, 2, 3, 4, 5, 6, 7, 8, dot, 4, 5, 6, 7, 8, dot, 1, 2, 3, 4, 5, 6, 7, 8, dot, and then only the 4th octet, 1, 2, 3, 4, 5, 6, 7, 8, changes. In a class C, you can only have 256 possible IP addresses because that's 2 to the 8th power. There's the 8 bits there. Okay, so again, a binary net mask is simply allocating the range of numbers that your computer thinks is on its local subnet versus what's not on its local subnet. The reason it's easier to understand binarily because you can literally count the 1s and 0s. Anywhere where you see a 0, that means that's variable, it's on your local subnet. Anywhere where you see a 1, that means it's outside of your range. So now if you were to apply to that subnet mask, and by the way, that translates into 255.255.255.0, pretty obvious why. If you see that subnet on your computer and somebody says, well, here's an IP address of 10.0.0.237. Is that local to you, yes or no? No. Is it on your local network? And the answer is yes, because these first 3 octets are the same. And only that last one differs on your network. If I gave you the address of 12.0.3.237, or actually, let me give you an even harder one, 10.0.1.237. Is that number on your local network? It looks very similar, but it's not because that 3rd octet was a 1, and based on your subnet mask, you said, oh, this cannot vary. Since my given address that I gave you there earlier is 10.0.0.6, right? My little laptop here is running on 10.0.0.6. That means that 0 can't change. So if that address was given to me in an email or a web request or anything, or I typed it in, whatever it is, my subnet mask is applied, which is given, usually by DHCP. It says, oh, that's not local to me. Don't throw it out on the local network. Send it immediately to the gateway. Send that packet to the gateway. It's not on your local network. Here's the default gateway. The default gateway always, always, always has to have an IP address. And bear in mind, a gateway has 2 IP addresses. Otherwise, it's not a gateway. A door has 2 sides. Otherwise, it's not a door, right? It's just a wall. Got the inside and the outside. So think of a gateway as a door. The inside of the door is a local network address, 10.0.0.1. It has to exist on your local network. You can't have a gateway address that you can talk to outside of your network. Otherwise, it's a door in another house. It doesn't do you any good. That gateway has a public IP address or an IP address on the other side of it. We don't care what it is. We might know, we can go use IP chicken and figure it out, but we don't care usually. We just care what it says on our side of the door that we can see. So that default gateway, that implies, by the way, that in your subnet range, if I said, hey, I've allocated you an entire class C. Here's a class C for you to use. I'm going to give you 132.58.10. everything. And here's your net mask, 255.255.255.0. Do whatever you want with that. So there's 8 bits there, you would think, oh, I've got 256 addresses to play with. Because that's 2 to the 8th power, even though we start at 0. No, because you lose 1. You actually lose 3. This is an important concept to understand. You lose 3 addresses because the very first address in this range of this class C 132.58.10. Oh, I put .0. It has to start on a boundary, by the way. That is called a network number at this point with that subnet mask. In other words, you can't, that's an IP address, but you can't give it to any host. If you try to do anything with that number, that's referring to the entire range. That's how you define and name the entire range. 132.58.10. Everything, aka .0, belongs to Jake. He can do whatever he wants with it. Here it is. Here's the piece of hardware that it's attached to. So you can't use that first number in a range. You also cannot use the last number in the range. What's the last number in this range? 132.58.10. What? What's the last number in the range? As I said, you have to start counting at 0. It's not 256, it's 255. Excuse me, 255. That's called the broadcast address. That's a special address that we can use to broadcast a message to everybody in the network, called the broadcast address. So we can't use that for a host. A host is any computer or workstation or server on the network that can pass traffic. We also lost one because we have to have a gateway, which is a special purpose device which is on our network. Unless you're using your computer as a gateway, which you don't usually do that. You used to a long time ago, and you can potentially, but we don't do that. The gateway takes up an address. Typically, not always, but typically, we put it, it's got to live within that range, 58.10. We usually put it at the very first available number, which is 1. That's why in my real world example here, my gateway's at 10.0.0.1. Now it could have been at 2, 10, 50, 200, 254. It can be anywhere in that range. But I don't recommend randomly, if you have control over your gateway number, I don't recommend logging into your gateway and making it a random number within the range. Just like the analogy of a bus driver driving a bus. It makes sense to put the bus driver at the front of the bus in the very first seat because he's the router. He's the guy that's driving the bus. Put him in the first seat. Or some networks like at U of H, for example, once you finally get back to U of H and you log on to the wireless network. Is anybody at U of H right now, by the way? Probably nobody, right? There's a few students that are living there and are allowed to be.
I'm 5 minutes from U of H, like 3 minutes.
Okay, but you're not actually on the network at U of H though, right?
No.
Okay. So if you were to log into the Wi-Fi network at U of H, you'll notice that your gateway address is probably something.254. And that's because U of H decided a long time ago, let's use the highest possible address in the range. That's left up to the network manager. But the point is, because of these 3 items, you actually lose 3, this is the sawdust, you lose 3 IP addresses every time you chop a subnet in half. So in the case of a, oops, did I just erase a bunch of stuff? Yeah, in the case of a class C, how many usable IPs do you have for hosts? Meaning servers, workstations, printers, phones, cameras. It's 2 to the 8th power minus 3, or 253. In a class B, How many network addresses do you have? That is 2 to the 16th power, which is 16.7 million. Excuse me, that's a class A. And that's 65536 minus 3, or 65533. Okay, you got that concept? Every time you split up a subnet, you lose 3 addresses. Now, Class A, Class B, and Class C are the 3 major groupings of subnet division, but we can further divide a subnet because we can take, if we go back up here to that net mask, we are allowed to take any of those zeros starting from left to right and turn them one at a time into ones in order to reduce the size of our subnet. So some of you might wonder, why do you want to reduce the size of your subnet? Well, for example, if you are only given a Class C, where's my tutorial? If you are only given a Class C, oh, I just opened it. Oh, there it is. As in this case, your entity, your company is only given a Class C by your upstream provider, but you have 3 or 4 different departments at your company, and you want to break those down even further for better network management, better network flow. You can break them down. You can break it down into any power of 2. In other words, you can cut it in half. You can cut it in fourths. You can cut it into eighths. You can cut it into sixteenths. You can cut it into 32nds. You can't cut it into the thirds or sixths or ninths or weird amounts like that. You can cut a network in half. So it's just like, think about taking a 2x4, cutting it in half every time. Or taking a pizza and cutting it. Maybe now pizza is not a good analogy. So if you were lucky enough to be allocated a Class C, I lost my mouse again. And you need to split that. Let's take a look at this table here. This is only the last 8 bits. Okay, pretend all the 11111's in front of it, but if I take the full 32-bit subnet mask, 1111111, 1111111, 1111111. Can't change any of those ones, but I've got 1, 2, 3, 4, 5, 6, 7, 8 zeros. Let's flip that leftmost 0 into a 1, and you always have to do it from left to right. You cannot have zeros intermingled in the ones. It's always some number of ones to the left, some number of zeros to the right. All you're doing is moving around where that change is. That translates into that. And I could show you the math, but I'm not going to. There's lots of subnet binary charts and calculators that you can use, but that's what the decimal net mask ends up looking like. Number of subnet bits and host bits, what this refers to is that subnet says I've got 1 subnet bit, meaning 2 subnets, because a bit can either be what? A 0 or a 1. So 2 networks. 7 of those bits, 7 of those 8 bits are for hosts. In other words, what is 2 to the 7th power? I've lost one of my zeros because I turned it into a subnet bit. Excuse me. Yeah, 2 to the 7th power is, what's half of 256? Somebody tell me 2 to the 7th power. Go Google it if you have to. Use all your fingers and toes. Thank you, 128. Thank you, Geronimo. So 2 to the 7th power is 128. Now you'll notice in this chart, and you'll see this on the internet a lot, hosts. What they're referring to is the number of actual hosts you can have on that network. Now they say 100, so they're only subtracting 2. That's technically true because the gateway address is a device on your network and you can access it. You can log into it, make changes to it. It's a host on your network, but it's a special purpose host. You typically can't do anything else with it. It's just your gateway. You don't typically run Windows apps on it, so it's not typically a usable workstation. So I differ, and my argument is you should always subtract 1 for the gateway. In other words, you're subtracting a total of 3 from every subnet. So when you come up with 2 to the whatever power, always subtract 3 from it. If we go back to this, if we flip another one of those zeros to a 1, we have 2 subnet bits. What's 2 to the second power? 2 to the second power is 4, meaning I can create 4 local subnets. And I'll show you the numbering in just a second here. 2 to the 6th power is 64, so I can have 4 subnets of size 64 minus 3, or 61. So if I decided I'm going to split up the class C that I've been given into 4 pieces, and my net mask is 255.255.255.192, which equals a bunch of 1s. I'm not going to write all the 1s again. Dot 1 1 1 2 3 4 5 6. Each subnet, because I have to lose 3 pieces in every subnet, normally would have been 64 because that's 1/4 of 256. But I have to subtract 3 for each subnet because each subnet has its own network number, its own broadcast address, and its own router or gateway. So it's really 61. So if we do the math backwards in the other direction, what is 61 times 4? And I'm just doing this conceptually to show you what happens. Here's the sawdust that's lost on the floor. 61 times 4 is not the same thing as 64 by 4. In other words, you lost 3 times 4. You lost 12 addresses. So it's no longer 256. It's now 242. Is that right? Did I do that math right? 256. 3 times 4 is 12. Yeah, 256 minus 12. 46. Yeah, 244. Excuse me. If I chop it down smaller, I lose. If I chop it in half again, so that I can end up with a little 32 subnets of 32 hosts minus 329 hosts. You see how I end up losing 3 every time you chop something in half? You lose 3 times the number of times that you're chopping it in half. So if you were to take your subnet and chop it down into a whole bunch of little baby subnets, and you would probably never use a network that small. This is probably the smallest ostensible subnet you would ever create in your office, because you're really creating a bunch of little networks. You're creating 30 little networks of 5 computers. 5 computers. I know it says 6 there, but it's really 5, because each network needs its own router. So let's go back up to the case of where I just took a subnet and chopped it in half. So I was given, in my example, 132.58.10.everything. I decided as a network manager, I'm going to chop it in half and reroute things as I want to. So the first subnet, the number is going to be 132.58.10.0. That's easy. The broadcast address, which represents the last address in that range, what do you think that is? It's going to be 127. Do you understand where the 127 comes from? If I go to 128, that's starting the next block. What a network number is doing, you can think, here's another way to think about this. A network number is defining the upper left corner of your subnet, assuming a subnet is a rectangle or a block of numbers, and your broadcast address is representing the lower right corner of your subnet block or your rectangle of addresses.
So you shouldn't have 255 at the end instead of 127?
Normally you would have 255, but I said chop that in half. So if you just count halfway into the middle of that range, you stop at 127, and then the second network, its network number is 132.58.10.128. That's its beginning and its broadcast address equals that last number. Okay. In this case, I will decide to put my router or my gateway, I should say gateway, excuse me. I'll use the first number in the range, 132.58.10.1. Here, what's the gateway address going to be? What should it be? It'll be the first number in that network, 132.58.10.129, because it's the first number right after that. You got that?
Yes.
Okay. Oops. So that's what I'm basically showing in this first example here. In network number 1 here. If I decided to split that network in half, this 192.168.1.0 into two pieces, the net mask for both of them is going to be 255.255.255.128, because it's that in that's in binary, it's that. You convert it to decimal. I flipped the 10 to a 1, so that's the same for both of them. The broadcast address for the first group goes from 0 to 127. If you were to count from 0 to 127, that's 128 spaces. The second network starts at 128. You count another 128 spaces up from there, you end up at 255. Not 256 because you include 128. Hopefully that's pretty easy to understand when you cut it in half. Now when you start cutting it in fourths and eighths, it's the concept is still the same, but you'll start losing where you're numbering, and that's where you should do that subnetting assignment. It says here the smallest subnet, by the way, you'll ever see is a 255.255.255.252, because that only gives you a 2-bit network to play with. What's 2 to the second power? 2 to the second power is 4, right? So if one of those numbers, one of those 4 has to be a network number, and the last number has to be a broadcast address, you've only got 2 hosts that you can have on that whole network, and one of them has to be a router. So a subnet mask and a subnet that small is only used to connect one office to another. Because it's such a tiny network, you can only have one device on it, other than the router. Now, if you were to go to Comcast, and this is also helpful. And say, hey, Comcast, I want some static IP numbers because I want to run my own servers or whatever. The way they sell it, and they sell it properly. Let's see. See if I can find a better link here. They'll either sell you 5 addresses. Well, they'll show you one static address. They'll sell you 1, 5, 13, or 29, or more. But this is how they sell it. Oh, here it is down here. They charge you more for it. So they sell in the blocks of 1, 5, 13, 29. And that's because that's really blocks of 4, 8, 16, 32, but they're subtracting the 3 out for you, which they have to in order to do that networking. So they're selling it properly in terms of what the end user's needs are. Now, like I said, if you go Google on the internet for these different binary net mask calculation charts, they'll have different columns, and they'll say number of subnets is this and number of hosts is 2 or 6 or 14 or 30, and that's because they are not taking into consideration the gateway address, the router address, the special purpose device you need on your local network that connects your internal network to some external outside network. So here's what I recommend that you do, because I want you to go ahead and get started on this now. You can do this little example here. I've got 5 different departments here. Each department has stated their needs to you, the network manager. They'll tell you we've got 12 PCs or 12 servers, 20 servers, 60 servers, 7 servers, 3 servers. Let's just say they're all servers, okay? Things that need some static IP addresses. It's your job to allocate the appropriate sized subnet for them. Okay, so here's how you do this. And again, you can follow through the tutorial, but I'll just mention a few things in the beginning here, how you do this. First of all, go through each department and take a look at their needs, and always start with the largest department first. These guys, they've indicated they need 60 IP addresses and might need to grow to as many as 10 within a year. So that tells you I better allocate 70 IP addresses. And this is the biggest entity. They have the greatest needs, so let's deal with them first. That's important because when you're allocating subnet sizes, if you're not careful, you end up wasting a lot of space. You can use the analogy of filling up a truck, or filling up a ferry. Let's use a ferry, a ferry boat that you drive cars onto. Has anybody driven onto a ferry boat recently or gotten on a ferry boat recently? Ferry boats carry all different size vehicles, cars, trucks, bicycles, people. So usually when you're getting on a ferry or you're queuing up in line to get onto a ferry, they've got different lines allocated. They've got one line allocated for big semi trucks, and they might have another line allocated for emergency vehicles or whatever. Then they'll have regular lines allocated for cars. Trucks are much bigger than cars. Think of each vehicle as a subnet. A semi-trailer truck is like a Class C. It's very large. It might take up 10 spaces, or let's say it takes up 8 spaces that one car might take up. So when the ferry operators are trying to maximize the space on the ferry, they put the big vehicles on first, drive them all the way to the front, and then let them take up those 8 spaces, and they get all of those in as well as they can. Then they start filling in the ferry with smaller cars at the backside. And they do that because they don't want to end up with a situation where they get 7 or 8 cars in a row on one lane on a ferry, and here comes a big semi truck, and well, it almost fits, but it's got 10 extra feet. Should we let that 10 extra feet hang off the back of the ferry? No, you cannot do that. Can't let 10 feet of truck hang off the back of the ferry. Or it may fall off the ferry. So you can't do that. So use the same concept. Deal with the biggest entities first. Has anybody ever played Tetris, or anybody ever tried to fill up a box with a bunch of smaller boxes? You don't put in a bunch of little tiny blocks first and then put big boxes in it, because you're going to end up with a lot of wasted space at the bottom. Put the big boxes or the big things in first. Or like, let's say you're putting away your toys as a kid. Put all the big toys in your toy box first, and then you can shove all the little toys in between the big toys. You'll be able to get them in there, okay? Think of that. I hope that's a useful concept. I teach that concept so people understand why this is a best practice. It's not necessarily written anywhere on the internet. I should probably write it down, but it is a best practice. Start with largest entity first, the largest needs first. Okay, so department C there needs 60, maybe as many as 70. So let's take that 70. Let's just write that down, 70. How do we figure out first how big a network is that they need? Here's how you do it. What power of 2 is greater than or equal to? Want me to blow that up a little bit? This is actually pretty simple, I think. Of course, I've been doing it for a billion years, but what power of 2 is greater than or equal to, in parentheses, 70, or the needs, I should say, plus 3. Always add the 3. Very important to add the 3. It's not part of your needs, it's part of your calculation. The needs is always going to be whatever the company stated to you, plus a growth percentage if they gave that to you, like plus 25%. So what power of 2 is greater than or equal to 73? What's 2 to the 6th power? Is that big enough? No, that's only 64. So it's going to end up being, in this case, 2 to the 7th power, which equals 128. So I'm going to have to use half of that class C I was allocated just for that first department. Now, if I was given larger than a class C or multiple class Cs, yes, I could give that entity an entire class C and be done with it. Say, oh, this is much easier to do the math. But the next best practice is do not waste space. Don't waste internet IP version 4 address space, especially if it's real public address space, because it's a limited address space. In other words, if you're a ferry boat captain and you're filling up your ferry boat, you don't put a Volkswagen in lane 1 and say, okay, we're done. Let's just let him have the whole lane, and then go to the lane 2, because you're wasting space. It's like everybody else is going to go, well, wait a minute, why can't we just get in behind the VW? And you go, well, you know how VW drivers are. They go in reverse whenever they feel like it, but whatever. My point is that don't waste space. If you do waste space on the exam and on the assignment, you will be counted off because you won't get the right answer, first of all. Two things here. You're trying to deal with the largest entity first, and you're trying to be efficient with your network subdivision. So 2 to the 7th power is 128. So let's figure out what our net mask is going to be. What's our net mask going to be? Well, our first 3 octets, we're going to give it a class C. We already know that our first 3 octets are going to be all ones. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. We just have to deal with that 2 to the 7th power. Well, there's the answer right there. That tells me how many zeros. 2 to the whateverth power, that tells me the number of zeros in the net mask. So here's one more 1, and then 1, 2, 3, 4, 5, 6, 7 zeros. There's my binary net mask for that company. See how easy this is? It's easy, right? And then all you got to do is calculate that and give it to me in decimal notation, because we as humans don't use binary. We don't type binary into routers and switches. We type in decimal. That ends up being 255, 128. 128. You can do the binary to decimal calculation if you want. I'm not going to teach you how. It's not really necessary, as I mentioned. I might as well talk about the slash. Well, I'll talk about slash notation in a minute. Binary net mask. Then at this point, you look at the subnet chart that you're given, and I usually give out, when you're doing these assignments, I give out a chart. Okay, so let's just, here's the chart of the class C. Okay, so I decided that I'm going to block out, and this is helpful if you guys do this visually by maybe using pieces of paper, drawing out literally a chart on a map, or using a spreadsheet. A lot of people open a spreadsheet and use columns of a spreadsheet to help them identify 256 spaces across spreadsheet. So I'm just going to say 129.7.1.0 all the way through 127. That is all going to be Department C. So I highlight that section in my spreadsheet and say nobody can use that. That's Department C. That tells me the answer for the answers for the rest of what I need to know about this company. Where should I start the network? 129.7.1.0, and that's because that was given to me already. I was given 129.7.1. everything through 127. Oh, I shouldn't say that. That's the number. I'm going to put the gateway at the first number, 129.7.1.1. The broadcast address is that's the lower right-hand corner here. So right there. So the net, if this was a two-dimensional block, which sometimes they are, there's the .0 in the corner, and there's a .1 right next to it, and then here's the .127 right there in that corner. Subnet masks can only be rectangles. They can't be any other weird shape. They can be a square, but they can't be a rectangle. They have to be a rectangle, and they can only be some power of 2. It can only be a rectangle of length 1, 2, 4, 8, 16, 32, 64, 128, 256. You can't have 132, even though it's an even number. You can't have 132 length rectangle. It's not a power of 2. 7.1.127, the range of usable addresses in this case is 129.7.1.2, because I can't use 1. It's allocated for the router all the way through the number just before broadcast. 129.7.1.126. And if you do the math on that, how many hosts can you have? 125 hosts. You could have also taken 128 and subtracted the 3 from it. How much address space ends up getting wasted there? Other than the 3 we have to waste. We take the 125, which is the max number of hosts, and we subtract the original needs, which is not 73. A lot of people make that mistake on the test. They go, oh, the needs is 73. No, needs is just 70. What's 125 minus 70? For those of you that are lazy.
55?
Yeah, 55. Use your calculator. So 55. So we have 55 wasted addresses that we can't use for anything else because they have been routed to that department on the hardware, on the cable. Okay, you can think of subnets. This is another good way to think about a subnet. Think about a subnet as a school bus. There are different sizes of school buses, but school buses only come in a certain number of sizes. They only come in powers of 2. So let's say you have a school or a school class that you need to take to the museum or you need to take somewhere, or you need to drive these kids from a particular neighborhood, and you've determined there's 57 kids in that neighborhood. Okay, so you want to get them all to be efficient. You want to get them all in one school bus. So you can order a school bus of any power of 2. Well, let's see, what's 2 to the 5th power? That's 32, not big enough. 2 to the 6th power, that's 64. Is that big enough? Well, let's see. That school bus has to have a bus number on it. That's like the network number. So you got to subtract 1 for that. The school bus also has to have an emergency exit at the back of the bus. And I don't know if you guys remember riding on a school bus to school, but usually, not always, but usually one seat is missing in the back of the bus because you have to have space to get out through that emergency exit at the back of the bus. So think about your broadcast address as the emergency exit, the missing seat. On airplanes, it's in the middle of the plane, but you understand what I'm saying. And then finally, you've got to have a bus driver to drive that bus because the kids aren't going to drive themselves. And until the foreseeable future, we don't have auto driving buses yet. Maybe soon, but not right now. So 57 kids, so I got to take 57 plus 3, 60, 2 to the 6th power is 64. That's good enough. Okay, so that means that I'm going to order a bus of size 2 to the 6th power, 64, aka 61 student seats in it. 57 students. I've got 4 seats left over. What should I do with those 4 seats? Can't do anything with it. The kids can get on the bus and you tell them sit in any of those seats. There'll be 4 seats left over randomly somewhere on the bus. That's an important concept to understand, wasted addresses, because with the current IP version 4 addressing and the way that we have to break up subnets, it can get very inefficient, especially if it's a large network. Now, sometimes we have to allocate larger than a class C. There's nothing that prevents me from eating into, let's see, 347. I'm going to try to finish up quickly. No, here's the full 32-bit subnet mask. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Let's say I've got an entity that needs 600 addresses. It's a data center, and they've got 600 servers. They need 600 IP addresses, all routed to this one data center. Well, 2 to the 8th power, aka 8 zeros, 1, 2, 3, 4, 5, 6, 7, 8. That's only 256. Let's flip this one here. Now I got 512 because I went up twice the size. Let's flip that one. Now I've got 1024. You guys see how I did that? All I did was flip some of those subnet bit ones into zeros. That translates into 255.255. Anybody know? That's not 252.0. That translates into 252, I promise. So that means if you had a range of 129.7.1.0 to 129.7. I'll say 200.254. Let's just pick a big range that we're given. What's my subnet block going to be if I stick them in the first chunk there with that net mask? Well, the network number, that's easy. That's going to be still the first number. 129.7.1.0. What's my broadcast address going to be? In that case, with my little chart here, and when you do the subnetting exercise, you'll notice the chart is actually multiple lines long. It's like 28 lines long. In this case, I've got to allocate 256, 512, 768, 1024. I've got to allocate 4 whole lines. In other words, I've got a truck that I've got to put on a ferry that not only is it the full length of the ferry, it's freaking 4 lanes wide. That's some big monster truck or something, or I'm moving a space shuttle or something. Okay, so I got to allocate a whole length of the ferry and 4 lanes. That's one whole side of the ferry. So that broadcast address is going to end up being, what would you think? The lower right-hand corner of that block is 129.7. Actually, we can't start it at 1. We'll start it at 0, excuse me. And I'll tell you why we can't start at 0 in just a minute. 3.255. That's the broadcast address. And that's because that happens to be the, okay, if the window you're looking at right now, can you guys see me in the window? the lower, let's see what, here, over here, the lower right-hand corner right there, pretend that's 4 rows down. So there's 0, 1, 2, 3, and it's the last address right here. So that's the broadcast address 129.7.3, 0123.255, not 1.255. And then the gateway can still sit at that same first seat 1. Excuse me, 0.1. And here's the reason why, by the way, we can't start at 1. Because when you allocate ranges, let's say you do have a vehicle that is 4 lanes wide on a ferry. Ferries only come in widths of powers of 2. Networks only come in widths also of powers of 2. So your ferry is either 1 lane wide, 2 lanes wide, 4 lanes wide, 8 lanes wide, 16 lanes wide. If I started at lane number 1, which is in the conceptual case of networking, that would be the second physical lane over. If I haven't started at the first lane, I started at lane 1, and I wasted that whole lane on the left side there. So now I'm trying to put a truck in a lane that maybe it can't fit, because in the middle of the 8 lanes of my ferry is the ferry house, or the stairs that you go up to, you walk up in the middle. So that truck cannot exist in lanes 1, 2, 3, and let's do it this way. Let's pretend lane 1 is actually physical lane 1. It can't exist in lanes 2, 3, 4, and 5 because lane 5 is on the other side of the tower. You'd have to cut the truck down the middle, and you can't do that. So when you're allocating subnet, and you'll understand this when you start doing the assignment. It's not that obvious now, but when you start doing the assignment, the first entity that you encounter literally needs 4 lanes, or maybe 2 lanes, but it needs 4. Can't use 3. It needs 4. You've got to start it at the beginning. Either you got to start at 0, or start at 4, or start it at 8, or 12, or 16. It's got to be some multiple. So here's what I want you to do for homework. If you haven't already studied to get ready to take your test, go through this tutorial. I pretty much just explained how I derive these numbers. See if you can conceptually understand that tutorial, and then go and actually attempt to do the subnetting assignment. And again, I recommend you do the paper version first. Let me pull this out here. Sorry, it's displaying funny on here. There it is, assignment. Oh no, you don't want to see that. What am I trying to show you here? I'm trying to get to the assignments. Things are moved around on me. You guys understand what I'm trying to show you? The assignment. Blackboard's changed a little bit on me. I'm just trying to find where it is. What in the heck? What is this? Blackboard. Blackboard singing in the dead of night. That's what I was looking for, that stupid little pull-out thing. Assignments. We're obviously not going to be able to do that network cable. Subnetting first try. That's the paper version. Excuse me. I'm just trying to look at it. There we go. I know it says it's due April 1st, 2019. I will fix that. But there it is. It's a PDF that you can download. The first thing you're going to see on it is this big chart, starting at 129.7.0.0. Your job is to take these 10 departments, there's 10 of them here, and allocate them into that chart appropriately, filling out each one of these lines: projected needs, net mask and binary, net mask and decimal, slash notation, which I did not mention, but it's described in the tutorial and it should be fairly self-explanatory. It refers to the numbers of ones in the net mask. See if you can get that tutorial done. Go ahead and turn it in. What I do is, here's how I recommend doing this. Print this out and actually use pens and pencils like you did back when you were in elementary school and shade in the areas as you go. As I mentioned, the first thing you need to do is scroll through all 10 and figure out which entity has the largest needs. There's my Facebook. They need 480 addresses. They're probably the biggest one. And do them in that order. In other words, do A, B, and C of all of them first. That's what I would do. Just go from 1 to 10, do A, B, and C. Because A, B, and C, all that these three items are figuring out, A, B, and C, is what the needs are and how big the network is. How big a bus do you need to get to that neighborhood? Forget about where to park them on the ferry, just how big a bus do you need, okay? Yes, you can do this without the VM. You don't need that. I'm going to go back and look through that stuff, but you don't need, the only reason you need that stuff for this class is to perform some of the Wireshark assignments, which we're not doing yet. So you can do this stuff, especially since you're just printing this stuff out. As long as you got a printer. You got a printer, Nicole? Or even if you don't have a printer, you can copy and paste that into a Word document if you want, edit it there. Okay, so again, you don't need the Citrix Zen desktop. You don't need VPN access to do this. Download this, do the paper version, turn that in if you want me to grade it. And then once you feel confident you understand this concept, you can go back and do the electronic version, which will auto-grade. It'll auto-grade itself. And the good thing about the electronic version is I allow you to turn that in as many times as you need to get it right. Here, let me change the view to student. I'll pretend I'm a student. That'll work. That works better. Okay, now I'm a student. So you guys are saying, I see what you guys see now, hopefully. So here's the subnetting assignment. This is an actual fill in the blank assignment. Again. And you are literally highlighting in. So for example, if myspacebook.com needed to fill in, and I've got like a spreadsheet here basically for you to fill in. It scrolls all the way off the screen. myspacebook.com is going to end up taking up the first 4 rows. So you're going to basically do this. Turn on the caps lock and do M, and you're just going to fill up the first 4 rows with M's. I've broken up this chart into little blocks of 16 for you. And then the next one is going to take up, I think, 2 blocks. I don't remember who it is. It's probably, if I had to guess, it's 2 to the 8th power company. So I designate it like this. And then you can submit that. It'll grade it. It won't necessarily show you what you got wrong, but it'll give you your grade. So if you got like an 85%, obviously you made a bunch of mistakes. Go back and redo it. So you've got until Saturday to do that one. Download that subnetting paper first. I'll talk about this again a little bit tomorrow because I want some of you at least to try this tonight and see how far you get on it. Okay? Any questions about this or anything else? Not the test, not the exam. Exam 2 is still open, available for you to take up to tomorrow at midnight, but again, you've only got 3 hours to take it. And it might say 2.5 hours in a couple places, but I extended to 3. You've got 3 hours to take it. That's the timer. It will, I don't know if it auto submits or not. So don't just assume it's going to auto submit. If it's 9:30 and you're taking the test and then you decide, well, I'm out of time, let me walk away from it. Click the submit button or it may not submit the test at midnight. I don't recommend waiting till tomorrow at 9:30, just in case you have internet issues. Okay? I'll see you guys tomorrow, Tuesday. I will most likely be able to start at a normal time. I'll send out an email. I'll post this.
Professor, can I ask you a question?
Sure.
About the EI lab, so I wasn't able to connect it. So what are we doing about, like, what should I do?
Don't worry about it. What you're supposed to do is whatever errors that you got on your screen, take a screen print of that, submit that as the assignment.
I did.
Several people emailed me and I said, no, don't email me. Actually submit that as the assignment. That way I can officially, formally, rather than just being all random in my email, go in there, grade it. So for the people that were able to do it properly, I can grade them immediately. For those that weren't, I'm not gonna count off, okay? I'm gonna try to figure out what was going on that caused you not to be able to set that up. Some of it is beyond your control. Some of it is simple, a typo somewhere or a missed step somewhere. So I'll take each case at a time there. And so if you were not able to, make sure you notate that somewhere in the assignment submission in the text box. I was not able to successfully connect, or I was able to successfully connect, and here's proof of that. Okay, so for those of you that are here that just emailed me without submitting the assignment, go ahead and submit it. Even though it was due yesterday, you should still be able to submit it even after the due date. Don't use the excuse that I couldn't figure it out, because that's part of the assignment. Okay, seeing if you can get it done. And I know there are technical issues with it. This is kind of the first time we're having to do this. So I will see you guys on tomorrow, 2 o'clock. Goku.
I just have one question last for you.
Okay. What's the last?
I borrowed a laptop from the UVH.
Yeah.
Windows. So it's not letting me to like install some of the software that you recommended for me. So in this case, I will just use my Mac for best. Like,
well, that, or you should be able to get the VPN working. That should be built into what you got.
I tried on both.
Okay, so submit that as an assignment. I'll take a look at your screen prints and see if I can help you figure out if we can get the VPN working on the Windows loaned computer, okay? If not, we can go to your Mac, but let's try to use that Windows computer, okay?
Okay, thank
I'll
you.
see you guys tomorrow. If you have any other questions, send me emails. Thank you.
Thank you, Professor.
You're welcome.